Hi everyone, we're back again, and today we will finish our AB calculus test solutions. I will explain some of the problem because beyond this problem there's too many concepts we need to know. Now, our today class is about AB calculus solution part 3. We did part 1 I think or part 2. Now let us start and see what we can do. Okay, we read to this problem number 6. Problem number 6. Look to problem number 6. Which of the following are antiderivative of f of x cosine cube x sine x? I have four functions. He asked you if you derive and this guy here, negative cosine 4x over 4, you will get this guy here. If that's true, that means this is true. And you're going to derive this guy, and if you get the same exact as this, that means you are right. The same thing for this one. Let me just derive all of them and show you some rules you need to master this topic. Okay, let us see. Now we have number 6, problem number 6. Problem number 6. That's what we have. The first function y equal negative cosine to the power 4x over 4. Okay, what the first thing I need you to know, which is this is the same as negative cosine x to the power 4 over 4, which is easy to deal with. Here on this side of the board, I will give you some rules. That shortcut rules. As example, if you have a function f x equal g of x to the power n, any power, to find f prime of x, what you do? You bring the n down, g of x to the power n minus 1, and you derive the function inside g prime of x. Good? Okay. Example for this one, quick. Look here. Example. F of x equal, I'm going to make it I'm going to show you how we can make this easy. 7 here, x squared plus 2x. Okay, x squared plus, I'm making plus 1 to the power 3. First step, make f of x equal x squared plus 2x plus 1 to the power 7. This is the index over 3. The second step is to derive f prime of x, 7 over 3, you bring it down. You leave this function the same. You leave this function the same. X squared plus 2x. The only change is 7, 3 minus 1. 7 over 3 minus 1. 1 over 1. And just to remember, just some fraction. Times 3. Times 3. 7 minus 3 is 4 over 3. 4 over 3. What the last step, guys, is to derive the guy here inside x squared plus 2x plus 1. Okay, derivative of x squared is 2x. Derivative of 2x is 2. The derivative of any constant is 0. That's my answer. Let us apply this rule here. Now I need y prime equal negatively. Now again, when you have constant in the denominator, you don't apply quotient rule. You leave the constant. Leave it as is. Don't touch it. Leave it as is. Negative. Bring down the 4. Leave cosine x as is. And 4 minus 1 is 3. Now, the only thing you have to derive the cosine. Everyone knows the derivative of the cosine is negative sine. Derivative of cosine is what? Negative sine x. Look, negative and negative, the first and the last. Put them together. It's going to be positive 4 sine x cosine. And remember, the 3 goes here, cube x over 4. That's cancelled with this. That the first answer is right. Okay, let us see the second one. I'm teaching you now how not only solving the problem, and you should leave this problem to the last. I'm going to show you when I back to the test that I did 2-minute problem to show you that how to deal with the test. Leave this problem to the last. What's my second function? Y equal my second function. Y equal the second choice. We have it. Y equals sine squared x over 2 minus sine 4x over what? Over 4. The same. I'm going to write these guys the same as this sine x squared, and here 2. Before I derive it, I need to simplify it. Sine x to the 4 over 4. Now, I have some problem down. I'm going to move it all down. I'm going to back to this guy. I don't need. I'm going to give you this one later on. Okay. Back to the problem. We're going to apply the same rule for this problem, that rule. The one there, just to remember it, this rule, because we have exponent. This rule. Okay. Y prime equal, you bring down the 2, you leave sine x, and you have here 2, and derivative of sine, what the derivative of sine, guys? Cosine x, and minus 4 sine x, and this guy becomes 3, 4 minus 1, derivative of sine again is cosine. Good. Over 4. I told you when you have denominator constant, just leave it. You see, I left it. Don't touch it. Stay the same. 2 cancel with 2, 4 cancel with 4. Watch here. I have sine x, cosine x. I have sine cube x, cosine x. I can take a GCF, greatest common factor, which is sine x, cosine x. What the meaning of taking GCF? Meaning you have to divide this guy by sine x, cosine x, and the same thing for the other guy. When you divide sine x, cosine x by sine x, cosine x, you get 1, and minus. When you divide cosine, cosine will cancel with cosine. You see that? This cosine, this cosine. And I'm going to write it in small handwriting here. That's what I did. You divide this by sine x, cosine x, and the same thing. You divide this by sine x, cosine x. Good. This 1 and this cosine cancel with cosine, and sine cube over sine x is sine squared. Wow, this is something we know, all of us. It's another rule. I'm going to put it here. Rule. I need you to remember these rules, please. 1 minus sine squared x equal, and 1 minus cosine squared x equal. 1 minus sine squared equal cosine. Square x, and 1 minus cosine squared equal, that's easy to deal with. Now, then this guy here equal this guy here, which is cosine squared. Then we have sine x, cosine x, time, we said this guy equal cosine square x, which is sine x, cosine cube x, which is also true. The last function I have is 1 minus, look the last function I have. I need you to play smart with the last function. Look at y equal the last function 1 minus cosine. He meant to use this function over 4. I'm going to do distribute the denominator 1 over 4 minus cosine over 4 x over 4. One minus 4 minus over 4. Just remember, we did this the first one we did. You see this guy here? Then y prime equal y prime equal, the derivative of this guy is what? 0. Minus, what the derivative of this guy? Cosine 4, look here. Look guys, it's the same as which one? Oh, here, right? It's the same as this guy here. And instead of derive it again, I know that this is the same as this guy. And this guy give me this, and I explained it completely. That means also the last choice is true, which is this is what I did. This negative, this guy negative sine x cosine cube x. Go back to the first one, it's the same, which is sine x cosine cube x, which is true. This problem took time because that if I'm gonna back to the test now and show you. You can repeat this 1 time, 2 times. That's good problem to master the derivative. Look here. I left it empty here. I left it empty here. You see this guy, what I mean? The first choice and the last choice are the same. The first and the last are what? The same. And 1 and 2 has to be, look here, if you want to play smart and if you derive the first one, how you do it in quickly, shortcut way. I know I looked at the problem, this guy for as a derivative and this guy the same. Then 1 and 3, right? Here. I need to make sure that what they are together. If this guy is the same, which is give me this choice, then my answer is here. Okay. Now let us go to number 7. Number 7 is easy problem. A derivative of e to the sine 2x. It's a rule. It's rule. What's the rule? Y equal e to the f of x, y prime equal f prime of x, e to the f of x, which is what I did here. The derivative of e sine 2x is cosine 2 cosine 2x. Okay, remember here, I'm going to put it here on this side because I have this. Y equal sine 7x. What y prime? You derive the angle, which is 7, and you leave the guy cosine derivatives, and you leave the same angle. Don't change the angle. Okay, we're done with 7. 8. Look to the problem number 8. I did it just to save some time. You can see from the graph. He said, refer to the graph below of the velocity of a moving object as a function of time. This v axis and the y-axis, and here in the x-axis my time. Look, he said, at what time has it reached its maximum speed? I need you to understand. Here we have 10 meters per second, and here we have negative 15 meters per second. Negative 15 does not mean it less. Mean the object moving in other direction faster. Make believe you're moving to the north with 10 meters per second, and your friend moving to the left with 15 meters per second. To describe the motion, we still, your friend moving to the north, the opposite direction, but faster than you with 15. Then that means at the time is 5 seconds. Over what interval does the object have the greatest acceleration? what I need you to know, that means, look here, A is for VT graph. For VT graph, A is what? As the slope of VT. Then I need to find the slope between 0 and 2. From here to here. The slope is rise over run, which is 2, which is 10 here. You see that? I brought it for you 10 here. Divided by the x-axis 5 meters per second. 2 to the 3. It's negative slope. It's a negative. This guy positive. This guy what? I'm gonna mention the positive by red and the negative by blue. Okay. Then from 0 to the 2 we have, from 0 to the 2 we have 5, right? From 2 to the 3 we have 10, the same thing, over but 1 but negative slope. From 2 to the 4, 2 to the 4, right? From here to here. No, look here. At 2, how much the difference in values? Look here, if you go here down, let me just do different color, green, this guy. At 4 here, if you go here, you find the velocity is -5. At 2, the velocity is 10. The difference between them is how much? -15. Why -15? Because I'm moving down, right? You see the line goes down with the negative slope, divided by 2. Now go to the 3 and 5. From 3 to the 5, the same, still we are negative. And the difference from 3, 0, 5, -15, negative, right? 3 to the 5, 3 to the 5. 5 is -15. Three to the 5, which is -15 minus 0 over 2, which is the same. 3 to the 5 the same as what? 3 to the 5 is the same as 2 to the 4, which is -15. You see that? 3 here and 5 is here. -15 and 0, which is -15 over 2, which is -7.5. The last choice is what left for me, which is 5 to 6. Look here, from 5 to 6, what we have the time? 1, which is 1, I have it here. And the difference is -15 to the 0, right? For 6, which is 15. And the curve going where? Going up with a positive slope. Good? Which is my answer. Good. Okay, this is 9. 10. I'm going to explain it in more details in there for the equation of the line tangent y equal cosine x minus 2 sine x. If you want me to, I'm going to explain it now for number 10. This is the y equal sine x plus 2 cosine x. Okay, I'm going to explain it one more time in my board. We said y equal sine x, y equal, for number 10, sine x plus cosine 2 cosine x. And the point pi over 2 and 1. Since he wants the tangent line. Then quickly I will write my equation. Y minus equal, I left something empty here, x minus, what I left? Look, the values in the blue, I have to have it. Slope and x1. This y1 I have it, and this x1 I have it. I need to find the slope. The slope, you find the slope is the derivative of the function f prime of x at what the value? This x1 and y1. x1, y1, which is at x1, which is pi over 2. Let us find our derivative. Y prime, derivative of sine is cosine, x. Derivative of cosine is negative sine, becomes negative 2 sine x. Okay, now I have the derivative. I need to find the slope. Slope is, we said, f prime of pi over 2, which is cosine pi over 2 minus 2 sine pi over 2. Now, cosine pi over 2 very well known, 0, and sine pi over 2 is 1. Then 0 minus 2 times 1, which is negative 2. Leave me back to my answer here. Y, I'm going to leave it red to find the equation, minus x minus, and I have all my values in the blue. 1, this negative 2, and this is pi over 2. Now simplify. Y minus 1 equal negative 2x plus pi. Add 1 to both sides of the equation. Plus 1. Y equal negative 2x plus pi plus 1. He wants this in the form of ax plus by, which is he wants me to move the negative 2x to here. Negative becomes plus 2x, right? Because it's negative. When you move it to this side, it becomes positive. Then I don't have to write the positive x. Just to show you, 2x plus y equal pi plus 1. Okay, one more problem. Look at it, just take 1 minute. Okay, good. 1, 2, 3. Okay, we have it. Now look here. Here this problem 11. I need you to see the graph of the function f is given here. What I did, I draw a number line right away here to check the behavior of the function f. Look, from negative infinity to this asymptote, which is the vertical asymptote, the function decreasing. Good? And from this point, which is negative 2 to the 0, the function stays increasing. Why I put a circle here? Because this is a vertical asymptote. The function is undefined. Then from 0 to the 2, the function start to increase. You see that? Increase. Going up, right? Then again, we have a vertical asymptote. I put circle, is the function increasing. What the meaning this f and this f prime? What the meaning? How this you can explain the derivative graph from the behavior of the function? When the function increasing, the graph of the derivative has to be above. Then from 0 to infinity, all the graph have to be above. You see that? From negative infinity to the 0, the graph is what? Below. Okay. Look at it one more time. Take your time. Take 30 seconds and see if you can understand it. Again, you go to the function f, and you see the function decreasing to here, to this vertical. Then it's still decreasing, negative. And from here, increasing, goes up, and here up, right? This mean for the derivative, this mean here, in the graph of the derivative is below, which is here. Which is here. And here the graph is above, which is here and here. Okay. Then that's my answer. Okay. Okay. 12. The function f is given as this x4 minus 8x squared plus 24x squared minus 32x plus 15. All of these statements are true except 1 and 3 are zeros of the function. You just plug 1 and 3 in the function. 1 minus 8, look, it's easy, plus 24, you find this one is true. You plug the values 1 and 3 in the function. B, f prime of 2, 0. What I did, I derived this one. Derivative of x4 for x cubed minus, right? 8 times 3, 24x squared. 2 times 4, 48x minus 32. Then I derive the second derivative because I need inflection point. For the inflection point, f w prime of x, 3 times 4 is 12, x squared minus 8 plus 48. What I did, f prime of 2, right, equal, wow, that's 0, good. Now f w prime of 2, it's what? Comes not 12 squared, right? 2 squared is 4, 48 plus 48, 96 minus 96. But this inflection point, I need to check, and right? I need to see this 0, right? Both of them give you what? 0. Now quickly he jumped and he told me 2 and negative 1 is a point of inflection. Point of inflection means the second derivative change the sign from negative to positive or positive to negative. When I look to the derivative here, look here, second derivative. 12 is out, x squared, 48 divided by 12, 4x, 48 divided by 12 is 4. Inside here is a factoring, x minus 2 and x minus 2. This equal, and I know from basic algebra, x minus 2 squared always positive, which is mean if w prime always 0 for all of x, that means no inflection point. Look here, increasing, decreasing. When he asks for increasing or decreasing, quickly you derive the function. And I showed you before how you derive this guy. Y equal 3 e to the sine x. Look what I did. Derivative of sine x equal cosine x. And you leave the constant here. Nothing happened to the constant 3. The only thing I need you to remember all the time in your life, e sine e to any power never equal to 0. Then we're going to deal with which one? With this guy, which is 3 cosine x equals 0. We divide by 3 by 3. Cosine equals 0. When cosine equals 0, between pi over 2 and 3 pi over 2. I showed you here, I left a small table. The cosine is positive at the first quadrant from 0 to the pi over 2, and negative from pi over 2 to the pi, and negative from pi to 3 pi over 2. That means quickly I'm between pi over 2 and 3 pi over 2. Okay. I think that's good for the day. Remember that we done up to problem number 13. If you have any question about any problem, I will be more than happy to help you guys. And to explain it one more time, please contact me anytime you want. Contact me anytime you want at this, either text me in this phone or send an email for this email for any concerns. Thank you and have a nice